Upon reaching the top of the building, the elevator accelerates downward at 3 meters per second squared. Construct a force diagram for the passenger. Okay, now let's do that. So we shrink the object, and downward we have a gravitational force on person by Earth, and there is a normal force right here on person by floor. Okay, so I am not going to show equality sign because the forces are not equal, because the object accelerates downward. Write an equation for the vertical forces on the passenger. So right now let's write down. So force of gravity pulling down, okay, in this case let me put the vector sign. Force of gravity, force of normal equals mass times acceleration. Okay, oh, I put G again, this should be A. Okay, so here let me put it here, the normal force plus m times G equals m times A. So after I write it down, normal force plus, so mass is the same object or same person, 85 kilogram, and gravitational acceleration is -10 equals 85 kilogram, and it goes downward. That's why the acceleration will be -3 meters per second squared. Okay, now let's see what's the normal force will be. Okay, so here let's solve it. The rest of them is math. Force of normal minus 850 Newton equals negative, so 3 times 85, 3 times 85, 255 Newton. Okay, so when you add positive 850 to the both side, then you will get normal force equals 850 minus 255 will be 595 Newton. So upward is going to be 595. So it is a, you see, like when the elevator goes downward, then the normal force got decreased. So when you step on the scale, when the elevator accelerate downward, then the scale will read less. Okay, actually we already done with this part. Calculate the force the floor exert on the passenger. We already calculated here. Okay, so the answer for the B is this part, the answer for the C is this part. Okay. So while descending in elevator, the cable suddenly breaks. How big is the force on the passenger by the floor? Explain. So we can explain with the word, but also we can show it with the math. So there will be no force by the floor because the person and floor, they are falling at the same rate. Okay, that's why floor will not exert any normal force back to the person. So we can put like they fall downward at the same acceleration. That's why the floor doesn't exert force on passenger. Okay, if you want to show it with the equation, so let's write down here. So force of normal plus mg equals m times acceleration. So here, when we plug the numbers, in case that they are falling, normal force plus 85 times -10 equals 85 times -10. You know, this part also mathematically normal force will be 0. Okay, so let's do the question number 5. Question number 5, it says that a 70 kilogram skydiver jumps out of the plane. Immediately after jumping, how large the skydiver's acceleration? So when an object in the air is gonna just gravitational force will act on it. That's why the acceleration will be negative 10 meters per second squared, or you can say negative 9.8 meters per second squared. Upon reaching the downward velocity of 100 miles per hour, 300 Newton drag resists the driver's motion. Draw a force diagram for the skydiver. How large is the skydiver's acceleration? Okay, so now let's show that. So there is a gravitational force downward and there is a drag force. Okay, so right now, since it's going down, it's getting faster, we can say that gravitational force acts on it is much larger, right? That's why we can write the equation like that. Force of gravity, force of drag equals mass times acceleration. So force of gravity, let's put it down. Okay, mass times G plus F drag plus m times acceleration. So right now let's plug the numbers here. So skydiver's weight mass is 70, and since I am out of space, that's why I'm not gonna put the unit. So gravitational acceleration is negative 10 plus force of drag is 300 Newton. So it's gonna be up because resist the motion. That's why it's gonna be up. Up is positive. That's why 300 Newton. And here we have the mass is 70 again. This is the object and acceleration. Now so far we apply our physics knowledge. Rest of them is math. So let's do the math. So negative 700 Newton plus 300 Newton equals 70 times acceleration. Negative 400 newtons equals 70 times acceleration. And here let's divide both sides with 70. Okay, so here we'll get, there's a negative here, let's do not forget that. 400 divided by 70 will be 5.7. Acceleration will be negative 5.7 meter over second square. So now you see that it is given the downward velocity 100 miles per hour, but we didn't use that. We didn't need to use that.